Hello, hi to everyone. Welcome to our channel. Today we are moving to the test series explanation about networks theorems. In the part of KVS TGT work experience teacher, in the UNIT-1 networks theorem concept is completed till now. So those are watching those 4 videos for networks theorem. After that, attempt the test series in the mobile app. After attempting the test series, you got some marks. So some questions you might be wrong. So where the explanation is needed, so that's why I provided the explanation for each and every test after complete the syllabus of particular topic. So still now you are completed the networks theorem syllabus. That's why you are moving to the explanation about networks theorem test series. So first here, the question here, according to the superposition theorem as applied to the circuit excited by more than one source. So here look at the options. So in case of superposition theorem, current source is contributed by each source, not only current source, we are consider voltage source also contribution. All voltage sources send their currents in the same direction? No, because in the circuit it is need not to be the same direction. Current in any resistor, just look at here, current, for example, this is the circuit we have. Current in any resistor equivalent to algebraic sum of the currents which source should send which source would send if acting alone. This is the option is correct, because according to the superposition theorem, the current may be the response in each source acting alone, the summation of all the responses, individual responses, equal to total current or total response. That's what here. Okay, option C is the correct option. In the theory class, I will give I provided the statement, superposition theorem statement. If you look at the superposition statement in the theory class, definitely this bit is very easy for you. Next, superposition theorem can be applied only to circuit having dash elements. What are the elements? Circuits having linear bilateral elements. Okay, option B is correct option. What is mean by linear and bilateral? For example, we have a resistor. I provided the current 2 amperes this side from A to B terminal, right? In the same current, I reversed it from here to B to A, the current will be same. So in case of resistor, it is a bilateral element. For example, you are taking the diode. For example, this is a positive and negative. You are connected like that. For example, this is a 2 amperes, no problem. In case this battery is connected here, the current will be not 0. Current will be not 2 amperes, 0 amperes in ideal case. That means current in both the directions are not same. That is called as a unilateral. This is called as a bilateral. Coming to the linear. So linear is nothing but for example, you apply the current or you apply the voltage, the response is current. The relation between voltage and current is linear. So obey these two conditions, superposition theorem is applied. Okay. Next, superposition theorem is essentially based on the concept of linearity. The concept of linearity, that is option B. Already explained what is mean by linearity. So linearity means the responses you are taken individually, summation of all the responses, you will get this total response. That is a linearity concept is applicable here. While Thevenin's circuit between two terminals, VTH is equal to. I hope that everyone our theory class the statement, right? Thevenin's theorem statement. According to that, what is mean by VTH? Already I mentioned VTH is nothing but a open circuit voltage. Where you need to open circuit it? Look at here. So in this case, open circuit terminal voltage, open circuit terminal voltage, right? VTH is nothing but a open circuit terminal voltage. Option B is the correct option. So what about remaining options here? EMF or battery nearest to the terminals? No. EMF or battery nearest to the terminal. So this B option is correct. VTH is nothing but a open circuit voltage. Next, coming to here, Thevenin resistance RTH is found. Thevenin resistance RTH is found. So what is, how to find out the RTH? In the statement of theory class, in the statement explained, just look at here. Between any two terminals, open circuit terminals, no. By short circuit given the two terminals, no. By removing the voltage sources along with the internal resistance, no. Voltage sources removed, replaced by internal resistance. Clearly look at the statement from the Thevenin's theorem. Between the same open terminals as of VTH, right? While you are finding the Thevenin's resistance, right? Open circuit terminal same as VTH. Your VTH you have found open circuit terminal, for example, these two terminals, right? Those terminals are used to find out the RTH. This is the way. So option D is the correct option. Okay. Next, Norton's equivalent circuit consists of a, in the theory class already I mentioned, Norton's equivalent circuit current source in parallel with, ideal current source in parallel with resistance. Okay, RN. So in this case, constant current source with conductance in parallel. Constant current source, conductance in parallel. In place of conductance, it is not conductance. Okay, you can take it as a resistance also. Resistance in parallel. Okay, coming to here, current source in series with the infinite resistance, no. Current source in parallel with current constant voltage source in parallel with the high resistance, no. Single current source and single voltage source, no. Option A is the correct option. Okay. Next, while calculating the RTH, that means Thevenin's resistance, constant current source in the circuits are, okay, constant, see here, replaced by open circuited. Yes, it is replaced by open circuited. Option A is correct. Replaced by short circuit, no. Replaced in parallel with other voltage sources, no. Converted into equivalent voltage source, no. So clearly see that in case of Thevenin's theorem, while you are finding out in the RTH, current source should be open circuited and the voltage source should be short circuited. If it voltage source is a practical, not ideal source, it is replaced by internal resistances. So in the option is given replaced by open circuit is a correct option. Okay, coming here, the Norton's equivalent circuit consists of 2 ampere current source in parallel with 4 ohm resistance. Thevenin's equivalent circuit is a dash voltage source in series with 4 ohm resistance. So it is very simple. Look at here. They giving current source 2 amperes and resistance 4 ohms. These are the IN, Norton's equivalent current. This is the RN. Terminals A and B. What they are asking here, this particular Norton's equivalent circuit is converted into Thevenin's equivalent circuit. Well, that's what here. Okay, how to convert? See here. This is the current source, right? Current source convert into voltage source. V is equal to IR. What is the I? 2 amperes. R is 4. That is equal to 8 volt. So that means here 8 volt is a Thevenin's voltage, right? And resistance is 4 ohms is there, same 4 ohms connected here. Okay, this is a Thevenin's equivalent circuit diagram. This is the RTH. So what they are asking, what is the voltage? What is the voltage here? 8 volt. So look at here, option D. Option D, 8 volt. Option D. Right. Coming to the next question. Two identical 3 amperes and 4 amperes Norton's equivalent circuits are connected in parallel. So two identical. That means here 3 amperes Norton's equivalent parallel 4 ohms. Okay. Circuits are connected. Two identical circuits are connected in parallel, right? One more 3 amperes. So here 4 ohms. Okay, this is what given. So with likely polarity, the combined Norton's equivalent circuit is what they're asking, combined Norton's equivalent circuit in between these two terminals. So it is very simple. See, this 3 amperes and this 3 amperes in the likely polarity, it is very important, same polarity. So both are forward direction only. Whenever both are forward direction, these 3 amperes added, 3 plus 3 6 amperes. Next, coming to here, 4 ohms and 4 ohms connected in parallel, 4 into, that is Rm, 4 into 4 by 4 plus, because it is not need to do the calculations. Whenever both the resistors are equal connected in parallel, half of the resistance 2 ohms, because it is objective exam, time is very important. Directly can calculate 4 ohms and 4 ohms both are same resistors connected in parallel. Resistance value is R by 2, that is 4 by 2 ohms directly. It is 6 amperes. Look at here, 6 amperes 4 ohms. Option A is a correct option. Still we have a circuit 6 amperes, right? A and B 4 ohms. Not A. 6 amperes 2, right? 2 ohms. 6 amperes 2 ohms. Option B is the correct option. I am sorry. Okay. Next we are moving to the next question. For abstractly maximum power, this one, maximum power from any two given terminals of a circuit. Okay, the load resistance across the terminal should be maximum power. Okay, see here, 4 times the internal resistance of a network. No, already maximum power transfer theorem statement from our theory class, equal to the resistance when viewed back from the terminals, right? So in the statement also it is clearly mentioned, source resistance is equal to load resistance, then only maximum power transferred from the source to load. The source resistance, load resistance calculation, see here, equal to the circuit when viewed back from the circuit. That means you are disconnected all the voltage sources and deactivate current sources. You look back from the load terminals, that is called as RTH. That's what here given, equal to the resistance viewed back from the terminals. So that is a resistance. Less than the circuit resistance, no. Greater than the circuit resistance, no. Option B is a correct option. So this is about the explanation about the test series for networks theorems. In the second test series, 10 more questions are I will provided based on the previous papers. Those test series is there. Thank you.